Good morning, students. Yesterday we studied the homologous series for alkynes. We studied their general formula CnH2n-2. It is an unsaturated hydrocarbon with a carbon-carbon triple bond. Today we are going to study the structures of alkyne. We know that there should be a triple bond between at least two carbon atoms, and hence we begin with the value of n is equal to 2, where n is the number of carbon atoms. Accordingly, the first member of the alkyne series will be C2H2. The name of this compound is ethyne. Let us see the structure. First, we will draw the carbon skeleton. In that, we will arrange the two carbon atoms. Since there are only two carbon atoms, there is going to be a triple bond between them. Now we shall distribute the two hydrogens. Coming to the first carbon atom, here we have a triple bond, means it is sharing 3 electrons with this carbon. So in all there is 3 pairs of electrons, or we can say 6 electrons are being shared between the two carbon atoms. So each carbon will now need only 2 more electrons to establish octet. So this carbon will form a single bond with one hydrogen, as well as this carbon will form one bond, single bond with another hydrogen. So each carbon is now able to establish an octet with 8 electrons. 6 here plus 2, that is 8. Again 6 for this carbon also, plus 2, 8. Since there are two carbon atoms, it is considered to be a derivative of ethane. But because there is a triple bond, the last 3 letters from the corresponding alkene will be replaced by YNE. So this is a derivative of ethane. We will use the root word eth, and instead of A and E we will write YNE, that is from alkyne. The last 3 letters YNE. So the suffix is YNE, which indicates that there is a triple bond between two carbon atoms. We can write this as HC triple bond CH. Here you can see that there is a triple bond between two carbon atoms, or we can even write it as CH triple bond CH. So this is the structure for ethyne. The next example is of propane. Here we have the value of n is equal to 3. So accordingly we get the formula C3H4. First step, show the 3 carbon atoms in one straight line. Right now we have shown the triple bond between the first 2 carbon atoms. We have numbered them in this manner, that is 1, 2, 3, so that the carbon atoms between which we have the triple bond gets the smallest number. So it will be 1, 2 and 3. So triple bond is between carbon atoms 1 and 2. And out of these two numbers also you will select the smaller number while naming the compound. Now the 4 hydrogen we need to distribute. We will start with the first carbon atom. It is sharing 3 electrons with this carbon. This carbon is also sharing 3 electrons. So in all there are 6 electrons, or 3 pairs of electrons, which we can see it in the form of triple bond. So this carbon, number 1, needs only 2 to establish octet. So it will form one single bond with one hydrogen. So now from here it has got 2, and from here it has got 6. So total is 8. Coming to carbon atom number 2. we can see that it has got a triple bond here with this carbon. So it has already got 6 electrons. And if you see here, it is forming one single bond with this carbon, means it is sharing one pair of electron with this carbon. So it has already got 8. From here it has got 2, and from here it has got 6. So total is 8 with this carbon, second one. So there will be no hydrogen that will be attached because all 4 valencies have been satisfied. Coming to the third carbon atom, we can see that it is forming only one bond here with one carbon atom. Still 3 valencies are free. So it will form bond with 3 hydrogen and it will share one pair of electron with each of the hydrogen. So 2, 4, 6 and 8 electrons now for this carbon atom also. So we get the compound propane. Here we have the triple bond between carbon atom 1 and 2. We can see it here, 1 and 2. Out of this, we will select the smaller number, that is 1. And we can give the name 1-propine or simply propine. Or we can even write prop, that is the root word, then 1, the number, and then YNE, that is indicating the presence of triple bond, which is used as a suffix. So suffix is YNE. We can even write the structure as CH, triple bond, single atom C here, single bond CH3. So this is propine. We can even change the position of the triple bond. Now if I show the triple bond here, I will have to start numbering from right side, 1, 2, 3, so that the carbon atoms between which the triple bond is present will get the smallest number. It is between carbon atoms 1 and 2, out of that the smaller number is 1. Similarly, here also we will distribute the hydrogen atoms. We will start from here, this carbon. It has formed only one single bond, we can see with this carbon here. Still 3 valencies are free, so it will form one single bond each with 3 hydrogen. So now 2, 4, 6 and 8. For octet, carbon has got octet here. Coming to the second carbon atom here, it is having 6 electrons from here and 2 from here. So it does not need any more. Octet is already established. So no hydrogen will be attached to the carbon atom number 2. Coming to the first carbon atom here, it is forming a triple bond, means it has got 6 electrons. It needs 2, so it will form one single bond with one hydrogen. So 6 plus 2 is 8. So octet for this carbon is also established. Name of this compound will also be propine or prop1-ine. So we can write it as CH3, single bond, C, triple bond, CH. So this is the structure for propine.